This is page 49 in our notes. Today this is the start of CFA 5 notes. This one is going to be standards EE. It is 4, 5, 6, and 7. I'm using blue and black. Those are my colors for today. So these notes in particular are going with standard EE4. This deals with equations and inequalities. Equations, if you kind of listen to the word equation, it has to have an equal sign to be an equation. Inequalities, we've actually done these before. When we were comparing, we used the less than or the greater than sign for inequalities. So it just depends on which one they ask for, which one they're wanting you to write. We're going to make a little chart. Our chart has a symbol that it has the meaning, and then I'm going to give you an example. So we'll go there for now, and then we'll add on to it as needed. So the first symbol I'm going to give you is the equal symbol. So that means is equal to. So if I say 12 times 4 on the left, that is equal to 48 on the right. This is an example of an equation. Remember, an equation has to have an equal sign. Put a little line here in our chart. The next example that I want to give you for a symbol is the equal sign with a slash through it. That means is not equal to. So 6 minus 2 is an example, and that is not equal to 2 minus 6. We talked about this before in the last test, that 6 minus 2 and 2 minus 6, you can't flip those around with subtraction, so they are not the same. The next example that I have is the signs like this. If you remember, one of these looks like a sloppy L for less than, and that is this one. Kind of looks like the words less than. Therefore, this one up here you would read greater than. So this sign is greater than, and this sign here would be is less than. So when you're reading these left to right, that's how you would read them. If you're reading it left to right, this one is less than. So let's give some examples of inequalities. 5 is greater than 3. You did this on test 10. 2 is less than 9. These are examples of inequalities. Both are inequalities. In other words, they're not equal to each other. One side is greater than the other or less than the other. Draw a line in our chart. Then I want this one to take up 2 spaces of our chart. So I'm going to write that it's the greater than sign or equal to. So it's like it has part of an equal sign and the greater than sign. So we read this, the meaning is greater than or equal to. You say it, both of them. It's either greater than it or equal to it. So an example of this, x plus 3 has to be greater than or equal to 5. So how do you figure out what number you would put in for x to make this true? Oops, I forgot to write x plus 3. Oops, x plus 3, there it is. X plus 3 is greater than or equal to 5. That looks better. So then you need to figure out what would you plug in for x to make this exactly true. To make it exactly equal, your x would have to equal 2, but instead of putting an equal sign, I'm going to put the exact same sign up there, greater than or equal to 2. So I remember this in quotes. I'm going to say same sign, same sign, same sign. Whatever sign is in your problem, that's your sign down here. To make this exactly true, why does this work? If x were to equal 2, 2 plus 3 would equal 5. If x is greater than 2, like 4, 4 plus 3 is going to give you 7, and 7 would be greater than 5. So that's how that sign works. We'll do one more in our chart. We'll go 2 more lines down. Kind of the opposite of the one we just did. Instead of greater than or equal to, we're going to do less than or equal to. So we say it is less than or equal to. So I might say y is less than or equal to $40. Where would this come into play? Maybe you have somebody say they're going to charge you $40, but they won't charge you any more than $40. You know that you're going to be paying either 40 or you're going to have less than 40 is what you're going to pay. And so that's the end of our table. 2 things that we should have learned here is talking about equations and inequalities. So I want to talk about the term equation. Equation means it has to have an equal sign, so that's very important. It has to have an equal sign. An equation is just a statement where 2 expressions are equal. A statement where 2 expressions are equal. Put this up here a little bit. So what are some examples where that would hold true? 12 times 4 is equal to what? So you need the left side of your equation to equal the right side of your equation. So that would equal 48. Or you could flip it around. You could say 48 is equal to 12 times 4. So the left and the right are equal. 2 expressions are equal to each other. You can flip them around left to right, right to left. Most people like it this way, reading left to right. They don't like their answer on the left. The other term we talked about is inequality, and we did this on test 10 as well. Inequality, you're comparing 2 things, and they are not equal to each other. So inequalities, we use the greater than or the less than signs. So now your statement's not going to be equal. You'll be comparing 2 unequal expressions. A statement that compares 2 unequal expressions. I'm going to give you some examples of inequalities. One example I would like to give you. X plus 3 is greater than 5. So in order to figure this out, what must our x be to make this exactly true? Like, what if this was an equal sign? X plus 3, how would I get it exactly to be 5? Exactly true. Then I'm going to put a semicolon here. Then our x would have to be 2. So then this is where I said before, same sign. Same sign. So you're not going to say x equals 2. You're going to put the same sign here. X has to be greater than 2. So that's kind of your answer here. This has to have the same sign. So why does this work? If x has to be greater than 2, which is the same sign we see here, a number greater than 2 could be like 4. 4 plus 3 is 7. That makes the left side greater than 5 on the right side. So that would make that true. Okay, another example here, you're going to see, what if I put 8 next to an n, which means 8 times n has to be greater than 16. Put a little semicolon, so what would n have to be to make this exactly true? 8 times n, what if we wanted it to be exactly 16? Then 8 times, you would have to put a 2 in here. But you're not going to say n equals 2. You're going to, again, use the same sign that you see here. same sign. So instead of n equals 2, you're going to use the same sign, which is the greater than sign. N has to be greater than 2. So this is how you solve for this inequality. So examples of n that are greater than 2. What numbers are greater than 2? Well, some examples, n, if it was greater than 2, n could be 3. It could be 4, 5, 6, continuing on and on and on because it goes on forever. So if I put a 3 right here, 8 times 3 is 24, and that's greater than 16. That's true. If I put a 4 in there, 8 times 4 is 32. That's greater than 16. That works. The next thing I want to do in our notes is I want to put some directions in here.